Let us consider a scenario where we want to identify individuals inside a shopping mall without using any vision-based techniques or wearable devices due to the challenges such as privacy issues and vision obstructions. Modern activity recognition techniques now have been focusing on Wi-Fi sensing techniques where we can use Wi-Fi signal disruptions to identify any human activity inside an environment. This project focuses on Wi-Fi sensing using a SIMO system for multi-person localization and activity recognition. Wi-Fi sensing is mainly done through Wi-Fi channel state information, which is also known as Wi-Fi CSI. Wi-Fi data captures the effect of multipath propagation of signals on the signal amplitude and phase. A Wi-Fi CSI data frame contains 64 subcarriers where only 52 of them carry data. This is the 4D CSI tensor which gives spatial, time and frequency domain information. Let's walk through our project architecture. First we collect and store raw CSI data, then we read the relevant CSI data which will be pre-processed. After pre-processing, interpolation and mean calculation is performed. Following the input data preparation, we feed the input data to our 3 ML models. Then the output results are stored in the database and finally visualized in our web application. In this project, we used low-power devices for our data collection purpose. Specifically, we use ESP32 microcontroller which has Wi-Fi capabilities to transmit and receive Wi-Fi CSI data. To transmit and capture these CSI data frames, we use the ESP32 Wi-Fi CSI toolkit. Since ESP32 microcontroller cannot capture CSI data as a standalone device, we used our laptops to capture and collect CSI data. In our scenario, we use active access point and active station configurations. Since our raw CSI data contained a lot of noise and outliers, we had to pre-process our data in order to get meaningful results. We used the wavelet filter for denoising and the Hempel filter for outlier removal. For localization and activity recognition, we used 2 different deep learning algorithms. Localization task was done using a convolutional neural network. We were able to achieve a test accuracy around 82% for the single person localization and 70% test accuracy for the 2-person localization. In this demonstration, we can see how our model predicts the location of a single person on a grid system. This demonstration shows how our algorithm detects the second person and predicts the location of both individuals. Next, let us move on to activity recognition. We used a convolutional long short-term memory network, also called convolutional LSTM, for the activity recognition task. Convolutional LSTM helps us to capture both spatial and temporal features which are essential for recognizing an activity. The model was trained to classify 3 predefined activities: standing, squatting and jogging. We achieved around 83% of test accuracy for the activity recognition. This demonstration shows how the convolutional LSTM-based neural network accurately predicts the activity carried out by an individual. To visualize our real-time results, we developed our own web application. Our React web application is capable of visualizing real-time locations, activities, and CSI amplitude plots. As further improvements of this project, we can implement this system for a non-line-of-sight scenario. Also, we can use an edge device for data pre-processing and predictions. Thank you.